Hello, Geo Honors folks. How's it going? It's Mr. Skis. I'm not there. Sorry, but welcome to the stream. Welcome to the video. This is my setup that I have for my other videos that I've made for other classes. This is what I stream from, um, on Twitch as well, right? I can switch between my scenes here and whatnot. Um, that was my Be Right Back screen. Anyway, so twitch.tv/math happens. In case you wanted to know, math happens. Anywho, so we are doing some trig word problems today. We did lesson 7.3 in class last time, and we're doing some trig word problems 7.4. So at this point, the sub should be, or the teacher who's covering, hello, thanks for covering. At this point, the quiz has already been taken, right? Over 7.3, the daily quiz. So good job on that. Glad we knocked that out. We're going to do the lesson, and then the rest of the time you can use to work on the assignment. So if we need a moment here, you can pause the video and we can pull out our notes. But I'm going to assume now that we're ready to go. And we're doing 7.4. We're doing similar problems to what we did last class, except word problem style. Okay? So there's more of a purpose. So here's like a situation that could border on a word problem. Obviously, we're going to get deeper into the word problems, but we're not going to dive head first quite yet. So let's read this first one. Find the length of the side labeled x, round the intermediate values, and I'll let you know what that means, to the nearest tenth. Use the rounded values to calculate the next value. Round your final answer to the nearest tenth. Okay, so let's get into the nitty gritty here. What were we doing before? We were saying, hey, here's this angle that I've been given. Okay, and we were labeling HOA. So let's do that together. 41 is the hypotenuse, and this dotted line is the opposite, and the bottom side is the adjacent. But we were given more than one angle. So let's talk about the other angle as well and label some stuff. I'll highlight it in orange. And what we have here is x is opposite. This is the hypotenuse, and the dotted line is the adjacent. So there's two separate triangles. So our labeling is different for each. Okay. So where should we start? That's sort of the idea, right? Like if I'm supposed to get to here, how am I going to like connect the dots to get to here? Hopefully you're thinking that we should start with this triangle. And the reason why we should is because we actually know something about it other than the angle. Like I'm completely clueless about all three sides. That's not going to get me very far. But I have an angle and a side. So that's where I'm going to start. I'm going to start where I have more information. Now, the follow-up question that we're asking ourselves is which side should I solve for? Okay? Like if I'm trying to learn something about this triangle, we should take this information and solve for the opposite side. Okay? Because this adjacent side has nothing to do with the other triangle. All right? So the opposite side is the shared side. So let's solve for that opposite side. So O and H. Which trig function do we use? Sine. Okay? So sine of 34 degrees equals opposite over hypotenuse. And we're going to use this equation to solve for the opposite side. Yep. 41 times sine of 34 degrees. So now let's crack open our calculator. Let's crack open our calculator and do that math. Let me do split screen here. Let's crunch those numbers. We've got 41 times, let's make sure we're in degree mode as well. Sine of 34 degrees. Make sure I'm in degree mode. There we go. And I got 22.9. And this is our intermediate value. So Think so. If you're not getting 22.9 on your calculator, maybe this is a good moment to pause if someone could do that, sub or one of you can stand up if we need to help each other with the calculators. So what do we need to remember? We need to be in degree mode and we need to not be using the inverse trig function. We need to be using the regular trig function, okay? So this is the intermediate value because it's not our final answer. Intermediate meaning like, in the middle, all right? We're not quite to the end. So there's that. Now let's use this new knowledge. We now know that this dotted side here is 22.9. Let's use this new knowledge to solve for the value that we actually care about, and that's x. So look back at our triangle here. We are trying to solve for the opposite side already labeled, and we just learned the adjacent side. O and A makes tangent, opposite over adjacent. So tangent of 48 degrees is opposite over adjacent, which we now know is 22.9. And now we do the same thing. Crack that open. What do we get here? 22.9. Oh, low battery. That's okay. We're not going to kill it. 22.9 times tangent of 48. I'm just going to double check I'm in degree mode still. And I got 25.4. Does that feel good? Are we all right with that? Too bad if you're not, because I'm not there to answer the question. But if we are, if anyone's stumped, again, feel free to pause, and then we could, and then you can resume it. But all right, there's that. Now let's sort of, this wasn't exactly a word problem, but it was definitely more of a puzzle, right? A little more difficulty because we had to use one thing to get to the next thing. Okay. So let's now go into the word problem. There's some little tips over here. Let's read those real quick. Let's read the tips. Draw a picture if you need to. Label the given parts, always, HOA, that sort of thing, and set up the trig ratios and solve. Okay? So, already have the picture already labeled. We love an easy problem like that. A loading dock at a factory has a 16-foot long ramp. So, this is the ramp in front of it, as shown in the figure. The ramp makes an 8-degree angle with the ground, as shown. To the nearest tenth of a foot, what is the height of the loading dock, and how far does the ramp extend in front of the loading dock? Now, what I really want you to, even though, yes, X and Y are labeled, I want us all in the room to know which one is which. Please, all of us here can read, and you need to be identify which one is which. What is the height of the loading dock? Which variable is that? The height of the loading dock is going to be Y. And how far does the ramp extend in front of the loading dock? That variable is going to be X. Okay? And I want you to know which one is which. When you read those sentences, don't just think of it as solve for X, solve for Y. I want you to know the meaning of X and Y. This is a word problem after all. We're solving for the height and we're solving for this distance in front of. So let's solve for both. We label our H, O, and A. Here's the angle. This is the hypotenuse. This is opposite, and this is adjacent. So if you want to solve for the opposite side, O and H make sine. So sine of 8 degrees equals opposite over hypotenuse. And then we're going to multiply by 16. They all feel very much the same, this one step. I'll plug that into the calculator in a second. And then if I want to solve for x, the adjacent side, I'm doing adjacent over hypotenuse. Now, why am I using the hypotenuse? If any of you are curious, like, why didn't you do O and A? Why couldn't you do both at the same time? Or you always work with you work with the given, right? You want to use the given information. It was given to you with a purpose to use it, all right? So you want to make a ratio using the 16. So we want to solve for the adjacent side, but we still need to use the hypotenuse. So A and H give us cosine. Okay. And now let's plug both of these into the calculator and we'll get our approximate distances. So 16 times sine of 8. What is that? 16 times sine of 8 is 2. Does it say how to round? No. Let's do hundredths just because we can. 2.23. And is this feet? Yeah, 2.23 feet. And then the other one, cosine of 8. Let's just go ahead and backspace that and replace it with cosine. 15.84 feet. Perfect. You feel good? So again, this is the height, 2.23 feet high, and a 15.84 feet distance. I don't really know the word you would use for that, but how far does it extend? 15.84 feet. Excuse me. Oh, I would edit that out, but I don't feel like it. So it stays in. I actually sneezed in the other my other video that I recorded too, and I said the same thing. Lol. All right. Continuing. A long ladder. A long ladder is leaning against a building and makes an angle of 68 degrees with the ground. The base of the ladder is 6 feet from the building to the nearest tenth of a foot. Tenth meaning tenth place. How far up the wall is the ladder? So, what distance are we trying to solve for? Lots of students think, oh, I'm just going to solve for the ladder because it's talking about a ladder. Like, this is the ladder. I'm going to solve for it. Well, you would be wrong because it doesn't ask how long is the ladder, it asks how far up the wall. This is the wall. Clearly, it's made of bricks. And we want to know how far up it is the ladder going to reach. I'll call it H for height. Actually, I won't. Let's just call it W. I don't want you to confuse H with hypotenuse. Okay. So we'll call it W for wall. That is the distance that we're trying to solve for. So please read the question. Do not make any assumptions. You have two options there, right? There's two distances that we're solving for. It's either one or the other. Read it carefully, make the right decision. Okay. So 68 degrees is our angle. The W is opposite. The 6 feet is adjacent. And the blank side, the ladder, is the hypotenuse. So we work with what we're given. We want to solve for the opposite, and they gave us the adjacent. O and A make tangent. So tangent of 68 degrees equals opposite over adjacent times 6 and call it a day. Plug that into the calculator. And we already solved. We're already done. 6 times tangent of 68 degrees. I don't know what that. Oh, I just opened the same app twice. That's silly of me. I meant to open decimal. 6 times tangent of 68 degrees. 14 is said to the nearest tenth, so 14.9. And we're dealing with feet. So decently high. 15 feet, that's pretty tall. All right. Find the angle of elevation if you are standing 400 feet away and the building is 800 feet tall. I don't really like that it gave away which angle was the angle of elevation, but it is where it says right there. Okay. Let's look at this picture though. Trig problems. This wording of angle of depression and angle of elevation. Um, elevation, elevate meaning going up, depress meaning to get down, right? When you're down in the dumps, you're depressed, right? So depressed to go down, elevate like an elevator. It makes you go up. I know elevators go down, but the point of an elevator is that it takes you up, so you don't have to take the stairs. Anyway, So, elevation and depression. So, notice something here, or maybe you can kind of, I don't want to point it out exactly. Do you notice something here? We have the ground and we have this skyline, if you will. Okay. How could you describe those two lines? They are p- p- parallel. I was egging you on. Hopefully, some of you were thinking that to yourself or you said it out loud. They're parallel. Okay. And what do we call this? Do you remember the buzzword for this? This is the transversal. Transversal. Are you still with me? You remember these words? And these two angles are what relationship? They are, this angle is on the right side of the transversal. This angle is on the left side of the transversal. They're in between the parallel lines. They are alternate interior angles. Okay. Oh, I just realized it said parallel and transversal right there. I was just so focused on trying to tease the answer to you that I didn't realize that it was being spelled out to you. Anyway, what can we conclude about the two angles? They are equal because there are alternate interior angles. So, angle of depression and angle of elevation are equal because they are alternate interior angles. Okay? Okay. So, I believe the next problem is going to talk about depression. So, or maybe the one after that. But this one's focused on elevation. So, we're worried about the ground going up to something. So, we're trying to figure out that angle. Do you recall what we do to solve for an angle? We still use trig functions, but we use inverse trig functions, okay? So we're still looking at the angle. We're still having the same thoughts. We're labeling opposite, adjacent, hypotenuse. But now when we go to write our equation, we are looking at O and A and saying, let us inverse those values. O and A makes tangent. And when we inverse 850 over 400, we solve for our angle. And that angle is approximately 850 over 400. 60, does it say nearest degree or anything like that? It doesn't really say. I'm going to do nearest degree. I'm going to say 65 degrees on the nose there. 64.7, rounding up to 65. If it tells us otherwise, I'll listen, but how about we just do nearest degree for now? Any questions? Again, maybe pause it, talk to a peer next to you if possible. Otherwise, we'll keep moving. Okay. What are we at here? 18 minutes long. Piece of cake. This video is going to be under 25. We can knock these out. Boom, 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 boom. Here we go. We have to draw some pictures. Finally, the good stuff. Maybe it'll take a little longer than 25 minutes because we have to draw. You are a block. So, we all speak English in the room? Y'all understand me? Please read the words carefully. Even if English isn't your first language, you are here. You're going to have to read these words. Read them carefully. You might have to read it slower. You might have to look up some definitions, but please read it carefully. Do not make assumptions. Do not make assumptions. Read it carefully. Okay? Read it carefully. That's all I ask. You are a block away from a skyscraper. Get it down. Get some things down. Boom! I instantly see something. I see a tall building, a skyscraper, and I see me standing away from it, somewhere over here. There I am. This is not a drawing. This is not a masterpiece. I know some of you are artistically inclined, and if you want to have some fun with it, you can, but don't let it distract you from the point that we're drawing a right triangle. When it comes down to it, our picture is some variation on a right triangle, right? That's all it is. In case you didn't notice, right triangle, right triangle, right triangle, right triangles. Okay, in case you didn't notice. So, you are a block away from a skyscraper that is 780 feet tall. Here we go. Here is the 780-foot tall skyscraper. Let me write that a little better. 780 feet. Okay? Your friend is between the skyscraper and yourself. Hi, friend. So you, friend, between the angle of elevation from your position, the Y, to the top of the skyscraper is 42 degrees. Okay? So that is our angle of elevation up to the top of the skyscraper. Got it? And then that is 42 degrees. And then the angle of elevation from your friend's position up to the top of the skyscraper is 71 degrees. Okay. To the nearest foot, how far are you from your friend? How far are you from your friend? We want to know this distance right here. Ooh, challenging. Maybe, maybe not. I don't know. It's up to you. So, some of you might be like, well, there's a triangle right here. Can we do something with this triangle right here? Oh, it got a little crazy there, did it? Can we do something with that triangle? I would love to, but it's not a right triangle. These trig functions are applicable to right triangles. We cannot just zoom in on this triangle and go, oh, opposite adjacent hypotenuse, because none of that is true. None of that is true. This is not, well, I mean, I guess this is the hypotenuse because it's the longest side. Like, it's not a right triangle. We're not, that's not how this works, right? We can't just do this to any old triangle. We can use these functions on right triangles. So, sadly to say, there's two triangles that we can use here, and that's the triangle made with our friend. That didn't line up perfectly, but you get the point. The triangle made with our friend, and the triangle made with us, like so. Okay? I didn't click into place, but you get the point. All right, I don't know why that's not working, and it's irritating me. Okay, I'm going to try it one more time, and if it doesn't work, I have to get over it because we have to move on. Okay, there we go. So, those are the two triangles we can work with. Let's look at, we are trying to find this distance. If you're not going to solve for it instantly, but if you're not sure where to start, just solve for something. Like just solve for something. Okay? Let's look at the red triangle. All right? Let's look at ourselves. Let's focus on ourselves, right? We're all needy. We all want to focus on ourselves. We all want attention. Let's focus on ourselves, okay? So, why? The y, right? This red triangle. What can we solve for? We have an angle. And what side do we know? The opposite side, way over there, okay? And then if we care about x, do we really care about the hypotenuse? I hope you're saying no, because the hypotenuse, I mean, yeah, it's sort of related, but I'd rather solve for this side than I would this side. So this is O, and then this entire side, this video is going to be longer than I wanted it to be because I'm sitting here blabbing and I can't draw triangles. This longest side is the adjacent. So let's do it. Tangent of 42 degrees equals 780 over A. Opposite over adjacent. Okay? This is a moment where the variable is in the denominator, so I need to cross multiply. You remember doing this? And then divide by the tangent of 42 degrees. And let's kind of follow those directions from earlier and go, oh, let's round to the tenths place for the intermediate values. Okay? Let's round to the tenths place for the intermediate values. So 78 divided by tangent of 42 degrees. And I got 86.6. Now, is anyone thinking the math that I'm thinking? How can we solve for x? If I know that this is now 76, what did I say? 86.6. What math could I do? Or what information do I need? I hope you're thinking, well, if the whole thing is 86.6, if we could just subtract this away, I would know what's left. And that's exactly right. We can take this blue triangle that we drew earlier and solve for its adjacent side. This is still opposite, but the adjacent side of the small triangle is that distance, right? So let's do the same exact math, except, so same exact math, except now we're doing it with the 71-degree angle. There is no difference between the two problems. There's no difference between the two. Except now we're doing it with the 71 instead of 42. It's still O, still A, still 780. The math is identical. 71 degrees. 71? 71. And I got 26.9. So, with that being said, what is the distance between me and my friend? 86.6 minus 26.9 comes to a total of, I probably could do that in my head, but why would I want to have a calculator right here? 59.7 feet. You feel good? I feel good. I also feel tired. It's starting to hit me. It's getting late. All right. Sorry that took way longer than I wanted it to, but I really wanted to explain it. That's probably the hardest problem there is. I remember that problem from a couple years ago. From the top of a tower, the angle of depression to a stake on the ground is 60 degrees. Tower, boom, vertical. Depression, meaning this angle downwards, boom. Those things, like, don't overanalyze, like, just draw a right triangle and everything will be okay. Okay? You got the ground, you got the tower, boom, right triangle, you got this downward trajectory, boom, 60 degrees. Okay? What did we learn from the image above? If this is 60, then this is 60. Well, we didn't learn it only from the image above. We learned it in our parallel lines unit, unit 4, I think that was for you guys. Um, Boom. We know alternate interior angles, that's 60 degrees. So, the top of the tower is 80 feet above the ground. So we know the tower is 80 feet tall. How far is the stake from the foot of the tower? This distance right here, because the stake's in the ground, and we want to know how far is the stake from the ground. So this whole 60-degree depression, like, yeah, this is technically the angle of depression, but we're using our knowledge about alternate interior angles to say that this angle of elevation is also 60. So that's what I'm going to rock with. We know this is opposite. We know this is adjacent. That's tangent. It's the same math all over again. Cross and multiply. I'll do it all the way out this time, though. And we plug that into a calculator. What do we get? Sorry if I wrote that too quick. Just write it down. Well, do you remember what tangent of 60 degrees is from our 30, 60, 90 triangles? It's, do I remember? Root 3, right? Root 3? What is it again? It is. Oh, wait, did we do that yet? Oh, wait, we didn't do that yet. Oh, shoot. Okay, never mind. Never mind. I thought we did that. Um, Tangent of 60 degrees, 46.2. Ooh, we just hit the 30 mark. I'm sorry. The video's going longer than I wanted it to. Hopefully you like looking at my face. Me, tiny over here. All right, dos más. A ladder leaning against a house. What did I hear? I heard house. That goes straight up. I heard ladder. That leans. What do I see? Boom, right triangle with the ground. Don't overanalyze it. It's always going to be a right triangle, but my house makes an angle of 30, or sorry, leaning against a house. A ladder leaning against a house makes an angle of 30 degrees with the ground. Listen to that carefully. A ladder leans against a house, but it makes an angle of 30 degrees with the ground. The 30 is not up here, the 30 is over here. Okay? The foot of the ladder is 7 feet from the base of the house. How long is the ladder? Boom. There it is. We don't care how tall the house is. Who cares how tall the house is? No one asked. So we know that this is the adjacent side, this is the hypotenuse. Cosine. Using L for ladder. Cross multiply and solve. What does L equal? What does the ladder equal? 7 divided by cosine of 30. 7 divided by cosine of 30. 8.1. Boom! Feet. I forgot to label the last one. Don't be my like me. Label. Label, label, label. Okay? Okay. La lastima problema. Okay, last one. Find the distance of BC. Did I say that right? La lastima, the last. The last problem. Sometimes you need to add lines to your drawing to create right triangles. Find the distance of BC. Sometimes you need to add lines to create right triangles. Do we have a right triangle? No. But as just stated, we could add our own line like so. That becomes 90. And if you think about it, if this whole thing is 110, that means this angle has to be 20 now, right? Because 90 and 20 make 110. You with me on that? Hopefully so. Find the length of BC. Ooh, is that the right way to split that up? Actually, I don't think so. Learning moment, right? Because if I do that, I made a right triangle, but I didn't make two right triangles. So we want to avoid not having right triangles. So let's do it that way. You with me on that? Let's do it that way. You might have to turn your head a little bit, but um, if we made a 90-degree angle here, well, that's not 110 anymore. It's going to be 90 and 42 make 132, and then the leftover angle is 48. And if this whole thing was 110, and we have now split it into 48 right here, well, then this angle, what's 110 minus 48? 110, oh shoot, 110 minus 48 is 62. And then if this is 90, this is 62, then the third angle, I don't know if all the angles matter, but I think it's good to have them down because we can, right? We can. So why not? That's 28. Okay. Solve for BC. We are trying to solve for this distance here. Well, does this problem look familiar? Because it's identical practically to the very beginning. We have created two right triangles, and we have a little bit of information here, and we want to somehow solve for this over here. So what can we do? Let's solve for the dotted line as we did in the problem way up at the tippy top. We know that this side is opposite and the 250 is the hypotenuse, and we have this angle right here, 42. So sine of 42 degrees equals opposite over hypotenuse. Boom. Opposite equals whatever this is plugged into a calculator. I'll do that in a second. We get some answer. Oh, well, I guess I need it to, I won't do it in a second. I'll do it right now because we need that to solve for the next part, right? Um, 250 times sine of 42 is 167.3. And then we take that 167.3, which is longer than I thought it would be, but it is what it is. We take that 167.3, which, if we're looking at the triangle, it's a good thing I solved for these angles, people, because I need an angle in order, 62 or 28, I don't care which, I need an angle in order to solve for this hypotenuse. The 90 is not good enough, right? I need one of the other angles. So it's a good thing we solve for those angles. So let's take the 28. We know that this is opposite and this is the hypotenuse. Sounds like the same problem, except this time we know the opposite side is the 167.3, the thing we just solved for, and we're trying to find BC, the hypotenuse. That was the whole part, the whole gist of the problem here. Find the distance of BC. So I will cross multiply, divide by the sine of 28. And BC equals whatever that is plugged into a calculator, which is 167.3 divided by sine of 28 is 356.4. All right, folks, we kept it under 40 minutes. Sorry, but I guess the word problem, the drawing takes time. But hopefully I was entertaining enough for you. I appreciate you watching with the rest of the time. So, reminder, what did we do? We did the daily quiz at the start of class, hopefully. If not, you're going to do that now. We just did the notes. And then with the remaining time, you can work on the practice. And how much further do we have? I don't mean to make this video longer than it has to be, but we have 7.5 and 7.6. And then that's the end. So we're getting close to test time, not quite there, but we're definitely, we've hit that halfway point. Okay. So appreciate your time. Appreciate you. Enjoy the rest of class and enjoy the rest of your day. Okay. All right. Here we go. Bye bye.